In our last video, we looked at the speed of light and then we looked at electromagnetic radiation and we saw how there's a connection between light and other forms of radiation such as X-rays and radio waves. What we didn't talk about was how the medium or the substance that it travels through can impact on that. As we learned with sound waves, different temperatures affected the speed at which sound moves. We also saw that with slinkies and other things. The material has an impact. So a couple things we're looking at is we're looking at what is the substance and how dense is it, and we're also looking at the temperature. A lot of scientists have prepared data tables that you can find online that'll give you standardized values for these. From our class textbook, I've identified two of them here. We have an N value, what's called the index of refraction. And so I've got it here for silicone and I've got it here for a sapphire. So nice precious jewels, or nice precious jewel sapphire. Okay. So the formula that we want to use when we calculate this is n. N is the index of refraction, and n is equal to the ratio of the speed of light compared to the speed of light through the substance, which we'll just refer to as v for velocity. So it's the ratio when you compare those two numbers, and you just get this index number. So quite simply, I can take that, and in this example, I'm going to find the speed of light as it moves through both silicon and a sapphire. So I just do my algebra. I do my algebra one time. It works for both problems. So here, the speed of light through silicon is going to be equal to the speed of light, and this is through a vacuum. Just remember, this is through a vacuum, the C. It's the ideal conditions divided by the index of refraction. So we're going to have 3.00 times 10 to the 8th meters per second. And we will divide that by the index of refraction here, which is 3.42. There's no units. It's just a ratio of the other two numbers. And it's quite simple. We end up with the speed of light moving through silicon. It's going to be quite a bit slower than it was through a vacuum. All of these will be slower than the speed of light through the vacuum. So if you end up with a number here that's bigger than 10 to the 8, you know you've made a mistake with your calculator. Okay, so there it is. Let's do the same thing here. We're going to do the speed of light through the sapphire, and this should be a little better. Silicon is pretty thick and it's a solid, but sapphires are beautiful jewels that look great when light travels through them. So once again, we're going to take the speed of light divided by the index of refraction. So we're going to have 3.00 times 10 to the 8th meters per second. Divide that by the n value 1.762, the index of refraction. And what we're going to discover here, 1.70 times 10 to the 8th. Quite a bit slower than it is through air or through the vacuum, but much better than it was through silicon. So that's how we can take our index of refraction and figure out the speed at which the material is going to move. Here's another question for us. Let's say someone offers to sell you a diamond. Maybe you got engaged and you're going to buy a diamond ring, or maybe you just want some diamond earrings. Who knows? And somebody's offering you a diamond, and you're like, "Wow, the price just seems too good. Am I getting ripped off here?" And you want to know, okay, is this a real diamond or is this like a fake diamond, a cubic zirconia? Okay, so what you do is you just, and you've probably seen this in the movies. You see the gemologists looking through a lens at the stone. Okay, so here's all I'm going to do is I'm going to say, okay, so I know that the index refraction is equal to the speed of light divided by the speed of whatever that is going through. And in this case, I know that the speed of light is 3.00 times 10 to the 8th meters per second. And in this particular example, look, I've calculated that. How we calculate that will be in our next video, but that's going to be 1.24 times 10 to the 8th. And when I do that and I divide, I'm going to get an answer of n equals 2.419. And remember, our units here, we have meters per second, canceling it with meters per second, so that's okay. There's our n value. Well, you know what? That looks pretty close to a diamond. Maybe you should buy it if you're into diamonds. That's pretty simple. The index refraction, once again, is the influence that the medium, and once again, medium means the stuff that the light is traveling through. How does the medium affect light? Things that are quite dense, like silicon in this example, silicon is quite dense. That affects it. And then the other effect is the temperature. So always make sure that when you're looking for these values, whether it's a textbook search or the internet, make sure you be very careful to the temperature. Make sure it's at the same conditions that the problem has. I will, on a last note, is just mention that sometimes these are offered at what's called STP, and that is standard temperature and pressure. Okay, so just be very, very careful what conditions you are operating in. Standard temperature and pressure, we're usually looking at here is like 20 degrees Celsius, which is 293.15 Kelvin. And pressure, we're looking at, I believe that's 1 atmosphere. Yeah, 1 atmosphere of pressure.